Hello friends. So this is the second part of this series, arrays and data structures in Python. Well, so now we want to discuss about the methods for creation of arrays. You have seen in the first part that there are very many different kinds of arrays, many dimensional, and inside the arrays you can have anything, any real number, complex number, integer, float, any string or whatever. So now we want to tell you how we can create arrays of numbers. Say np.arange. Arange is a function with which you can create an array of numbers. Like range was a function used in basic Python, in core Python. So in NumPy there is a range. So inside the arguments, essential arguments are start. You have to start from somewhere, then you have to stop somewhere. Of course, in this you will see that like range, you don't touch the end button, and don't touch the stop button. You stop before that, and then comma step. That means you give the step size. So if you remember these three things: starting, stopping, and there are the step size. So let us see np.arange. Since I write here the first 0, so it will start from 0 and it will try to go here. It will create numbers between 0 to 3. 3 is the stop, but of course it won't touch the stop. And since I have not given anything else, that means it will assume that step size is 1. So it will create an array 0, 1, 2. Step size is 1. Now, if we write np.arange only 3, that means it will assume in Python that it will automatically, by default, it will start from 0 and stop at 3, that means less than 3. So it will again create the same array 0, 1, 2. Now, if you write np.arange 3.0, that means the argument is now float. You have seen in range that the arguments are all integers and it will create a list of integers only. But arange is something special. It can create float numbers. So if you write np.arange 3.0, see the result: 0 point, 1 point, and 2 point. Well, if you write np.arange, the start is 3, stop is 15, and step size is 2. And of course you can give this keyword argument d type equal to f, quote unquote. Although these three things, 3, 15, 2 are in integers, you can declare that the array will be of float numbers. So you have got this 3 point, 5 point, 7 point up to 13 point, because the step size is 2 and it cannot touch 15, so it will stop at 13 point. Well, if you write np.arange 0.5, comma 1.0, comma 0.1, and you have not declared the type, data type, but it has assumed that since the elements are in the arguments here are in float, so you want an array in float only. So you will get this. It will start from 0.5, end at 0.9 in step of 0.1, because it won't touch 1.0. Okay. Now there is another function which you can use. It is called Linspace. Linspace is linear space. It will start the arguments here is start and the stop or end, and you don't, instead of step size, you give the total number of elements you want. So if you write this 10, 20, 5, that means you want 5 numbers, not 5 steps. So you will get, and the array you got automatically in float. You have not declared anything, but you have got automatically in float. So it is 10 point, 12.5, and up to 20. And see, it is now here touching 20, because it is otherwise if you have not said otherwise, it will touch the endpoint here. That is the difference. And the step size, it has calculated by default, because you have given the task of creating an array where between 10 to 20, and you want 5 numbers, so automatically the step size will be 2.5. you see. Well, now if you write np.linspace and 1025, same thing, but you declare with a keyword argument that endpoint equal to true. That means the endpoint is true, it will reach up to endpoint, which you did here. But you can also declare with this, and you got the same array 10 to 20 instead of 2.5. Now if you write this, instead of endpoint equal to true, you write endpoint equal to false. That means you want 5 numbers, but you don't want to touch the endpoint. So you got 10 point, 12 point, 14 point, 16 point, and 18 point. So now the difference is changed. So it is now 2.0 instead of 2.5 that you got earlier. So that way, with endpoint true or false, you can also control this. There is another keyword argument which is called ret step. Ret step is return step. If you write ret step equal to true, it will then tell you what is the step size. You can see the step size is 2.0 here, but in many places you may not immediately quickly calculate the step size. So it will give you the step size. So if you write this, the answer is in tuple. So see, here is the first, the parenthesis starts here and ends here, and the inside you got the array and comma, this red these things is your step size. So you see the step size is 2.5. Okay, now there are other kinds of scales. This is a Lockspace, np.lockspace. So it will create some numbers between 0 to 1, and it will create 10 numbers. Let's see what it does. See, it has created an array. If you can't understand the numbers immediately, but if you take the log of each of the numbers, it will give you the Linspace numbers. So it will basically create numbers between, so if you take log of 1, it will be 0. If you take log of 10, it will be 1. So you can understand, if you take log of these numbers in these arrays, you will get the equispaced numbers in that you got in Linspace. So it's a Lockspace, you call it Lockspace. So by default the base is 10. So you can also write, so suppose you write this x equal to np.lockspace, the same thing, and you rename it as x. Okay, now you take log of x, that means np.log10 base 10 of x. Log10 is a function in Numpy, you can have in math module also. So you got the numbers here that I told earlier. So because see, this is starts from 0, ends at 1, and the step sizes are 0.111 something. Okay, so this is what Lockspace works. Also, you can modify a little bit the Lockspace. If you write in the argument 0, 1, 10, and then this keyword base equal to 2, that means you want to create an array of numbers, of which if you take log base 2, then you got the Linspace numbers, equispaced Linspace numbers. So this is what you get. If you take the log 2 of 1, it is 0. Log 2 of base 2 is that is 10, and so on. So you get the numbers. Okay. So there are very many different kinds of the functions with which you can create different arrays, different kinds of number arrays. Now you want to check the shape of the arrays, and you can reshape them also. Suppose you have created an array like this, 0 to 60, in terms of in step of 5. So if you write A, it will give you 12 numbers from 0 to 55 because it won't touch 60. Okay. Now you want to check what is the shape of these numbers. Of course, this is an array. This is an one-dimensional array. So if you look at this shape, the shape is 12, there's nothing. That means this is a tuple. This is a tuple where the total members is 12, and since there is nothing, this is basically one-dimensional. Okay. So also you could check with a.shape command, because shape is now an attribute of array A. A is already a NumPy array you have declared here. Okay, so the answer is the same, 12, Now suppose you want to reshape the array because there are 12 members. So if you want to reshape the array A in 3 by 4 this way, the shape will be 3 by 4. That means it can have 3 rows and 4 columns. Okay, let's see. So if you write that, you will get the first 4 members as 1 row, second row, third row, and 1, 2, 3, 4, then 4 columns. That means you have created a 2-dimensional array from a 1-dimensional number array. Okay, let's see this. If you write a.reshape also in bracket 3, 4, instead of np.reshape a, 3 by 4 as a tuple, you could also write as an attribute a.reshape. Inside you write 3 by 4. You could also now want to know what is b. The b would be the same. And if you now want to write, check what is the shape of b. The shape of b is 3 by 4. Also you could check with b.shape. The same way, same thing. It would give you 3 by 4. Okay, now unique elements. Okay, sometimes you have an array where some numbers are repeated. You want to know from a large array what are the unique numbers that constitute the array. So see, here is the array. You have 1, 2, 1.5, 10, 2, 10. So the 1 is repeated, say 10 is repeated, 2 is repeated, and so on. So if you want to know what are the unique elements, of course, so you can use this unique method, a unique function. So np.unique of y. If you check, the result will be 0.5, 1, 2, 10. So the basic elements that comprise this array. So if you also can create, say, another example. So if you know that in NumPy there is a random module which has many different random number generators. Random numbers are the numbers that comes something in a way that they have no correlation between one and another. So you cannot predict what is the number coming next. Okay, so inside the random module, there is a say random number generator. It's called randint. There are very many. There is uniform, there is Gaussian, there is many other random number functions or random number generators. You can go there and check with help or something. So randint, inside you, if you write 0, 2, 4, 5, that means it will create random numbers between 0 to 2, but it won't touch 2 according to the making of this random number generator. So it will basically create random numbers by 0 and 1. So 0 and 1 will come randomly, and it will create an array of 4 by 5. Okay, so let's see what is L. L is 0, 1, 0, 0, 0, something, whatever it has appeared. Now, if you want to check what is this array made of, basically, if you write np.unique L, you will get 0, 1. So the basic elements are 0, 1. So that way you can check any huge an array where you want to check what are the basic elements that will make the array. Okay, so if you now check this np.array, and all are strings a, b, b, a, something, something. So the same way, if you write on the interpreter, it will show you that the array is made up of 3 different strings a, b, c, and the data type also it has declared as string 1, size is 1. Now the iterator, you create an iterator. How do you create? You iterate something. So the arrays are iterable because it has many components like tuple, like list, all are iterators or iterable. So to do this, just to check this, suppose you have created an NP array 10, 20, 30, 40. Okay. So right, for I in X, so you create a for loop colon and then you write print I. Of course, it will give you 10, 20, 30. Since the loop is going on, so it will give you all the numbers 10, 20, 30 and 40. Okay, well, so the arrays are like, of course, it has many components. So it will be iterable. So it's an iterator. So if you also have say another array, it's a two-dimensional array because the same numbers as the numbers 0 to 60 in step of 5, and you reshape that in 3 by 4 that I did earlier. So if you because it will then be a two-dimensional array, means it will be a 3 by 4 array. So for I in A, and if you write print I, that means it will take one array, one row at a time. So if you write this for loop, and it will you will have first row, second row, third row as printed. So this way you know that this is a two-dimensional array, and you got this looks like a matrix. Okay. So consider this same array. Now, if you for I in, you can also do it in a very in a different way. You can use this nd iter. So this is a function. This is a function where you put the put the array A, and you in the keyword argument you write order equal to quote unquote f, and you write inside you write print I comma, you give I comma means it will print horizontally, it won't print vertically so as to save space. So okay, fine. So f means actually Fortran. So it will print the numbers in the style of Fortran does. So in this nder, what it does, it takes all the members one by one, but in which direction? It can go along a row, and then from another row, then another row, or it can go by like this, one column, one column, one column. Let's see what f does. F is Fortran style. If you print this, it will tell you, it will print you 0, 20, 40, and then 5, 25, 45. So you can see here that it is going one column after another. So this is the first column, 0, 20, 40 is the first column, 5, 25, 45 is the second column, and so on. But now if you write the same thing, and the order is C, that means it's a C language style. So if you write that, sometimes these are useful, and you get the result as 0, 5, 10. That means 0, 5, 10, 0, 5, 10, 15. So it is printing the first row elements first, then second row elements, and so on. So F prints in the column wise, reads column wise, and this is order C means it reads row wise. Okay, so this is the end of the second